So what I've got up here are 5 types of equations that you might need to balance, complete and balance in an NCA assessment. They're also pretty good examples to check how good you are at these things. I'm going to go through one way you could do this. I'm not saying it's the way, I'm not saying it's the best way. It's a way that I've found works for me, so hopefully it'll work for enough of you that it's worth going through. So, first thing that I do when I see an equation, whether it's a word equation or a symbol equation, is I look at what type of reaction is this. So I identify what the reactants are. So here I've got magnesium, which is a metal, reacting with HCl, which is an acid. Well, I know that when they react, they always make hydrogen and a salt. Alright, so I can automatically chuck in H2, not H, H2 for hydrogen, and then look at what my salt will be. Because it's hydrochloric acid, the salt is going to be a chloride, and because magnesium is my metal, it's going to be magnesium chloride. So, after identifying what type of reaction it is, I've then got to work out what the formula of my product is. So for that, I need to look at my ion table. And on my ion table, it has Mg with a 2 plus next to it, and Cl with a minus next to it. Well, they don't cancel out. I need 2 chlorides to cancel out the positive 2 charge of the magnesium so that the ionic compound is electrically neutral, so it has no charge. So, therefore, I need 2 chlorides, 1 magnesium, and you might know the process of drop and swap, where you take the number, I'll put them next to each other, take the number, drop it and swap it. It's a process, it's not a reason, so you can't say, oh, it's this formula because of drop and swap, but it's a way you can work it out. So it becomes MgCl2, so I'll write that into my formula, into my equation, sorry. Now I can see quite obviously that this is not balanced, because I've got 2 hydrogens here but only 1 in HCl. I've got 2 chlorides here but only 1 in HCl. So I'm going to need 1 more hydrogen and 1 more chloride. I'm not allowed to change the formulas now. I'm in step 3, which is balance the equation. I'm not allowed to change formulas, so I can't use little numbers. I have to use big numbers. And that's big numbers in front, so I can change the quantity of things, but I can't change their formula. Well, if I need 1 more hydrogen and 1 more chloride, then I actually need 1 more hydrochloric acid. So I just put a 2 in front of that. What this means is magnesium plus HCl plus HCl. It's just a neater, tidier way to write it. Alright? That one is probably our easiest of the ones up on the board. So I'll go through some slightly harder ones. Actually, no, the next one's pretty easy too, but it's just working out what would be the products. So here, I've got a carbonate or a hydrogen carbonate. Now, whenever these react, it's quite easy. You're going to get carbon dioxide. They react, you get bubbles. That's CO2. In this case, it's carbonate and acid. So I know that I'm going to have CO2. Well, carbonates are an example of a base. So a base plus an acid also makes water. So I'm going to have carbon dioxide, water, and a salt. So again, I can put a few of these in straight away without actually doing any hard work. CO2 plus H2O. Now I've got to work out that salt. Again, step 2 in my process is to look at my ion table to write the formula for the salt. So I look and I've got sodium that I haven't used yet, and I've got sulfate that I haven't used yet. So I look at those and they are Na plus and SO4 2 minus. Again, those charges don't balance out, so I take the number, I want to put the number on it, and I drop and swap it to make Na2SO4, sodium sulfate. And just to check, here that means I've got 2 sodium ions, so 2 positive charges, and the sulfate provides 2 negative charges. They cancel each other out to make sodium sulfate, the compound, electrically neutral. Okay? So that's those 2. I'm going to skip the next one because that's a bit like being on a seesaw. We go backwards and forwards a few times. I'll put it in the middle so it's in the middle of our screen because it is the hardest one. So I'm going to jump all the way down to this one here. Now I've got aluminium hydroxide and sulfuric acid. Now, aluminium hydroxide is a bit of a funny chemical. It can actually react with acids and bases. But in this case, it's acting like a base. Alright, so if you see metal hydroxide this year, it just means that it's a base. So it's a metal ion with hydroxide ions, it's a base. And we're reacting with an acid, so this means it's a neutralization reaction, which means we're going to be making water and a salt. Alright, so we need to work out what that salt is going to be. This one's a little bit harder to balance for the salts formula, that's why I put this one up here. Because aluminium, if we look on our table, is 3+, and sulfate is 2-. Well, neither of those cancel out. So actually what you need to do is have it find the lowest common multiple, which means times two numbers together. And that's going to be 6. So I need to get this to 6+ and this to 6-, so that the charges cancel out. So what that really means, for doing it really quickly, is I take the 3 and I put it over here, which means this will need to be in brackets because otherwise it will say SO43. It's not, it's 3 SO4s. I take the 2 from here and I put it over here. Alright, so what is it going to look like? Well, it's the Al2, the 2's come from the sulfate charge. Okay, it's actually given us a +3 here. Bracket, SO4, close brackets, 3. Alright. So the reason I put that one up is because of this being so hard. For balancing the actual equation, it's quite obvious that, well, if we've got 2 aluminiums, we probably need to have 2 Al2O3s. So let's put that there. Right, that will therefore give me, and if we've got 3 sulfates, I probably need 3 sulfuric acids. Okay, 3 sulfates, I probably need 3 sulfuric acids. So I can do that. Then I need to check how many waters do the hydroxides and the H2s, H+s, make. Alright, so I've got 6 and 3 times 2, another 6, so 12 hydrogens in this, which would make 6 waters. And I've got 3 times 2, so 6 oxygens. Again, that would make 6 waters, so that's good. So it's quite a lot of water being made in this one, 6. I would suggest, while you're learning this, to actually go through and add up how many sulfurs on the left-hand side, how many sulfurs on the right-hand side, how many oxygens on each side, how many hydrogens, until you get confident at it that you know that you're doing it correctly. So that's a time-consuming one. Probably still only really looking at contributing towards merit though. It's not quite as hard as this one. Okay, our last one in order, as it were, is this one here, where there's only one reactant. So it's doing something on its own, as it were, just by being heated. This is what we call thermal decomposition. For those doing physical science, you need to know about this as a type of reaction. Carbonates, whenever they react, make carbon dioxide. That's an easy thing to remember. So you know you're going to have carbon dioxide. Well, actually, then all you do is just find out what's left over. If I take CO2 out, I've got a copper ion and an oxygen atom, haven't I? I've got copper and oxygen left. And that's exactly what you end up with. So it doesn't actually need balancing. It's just checking that you do know that this is called thermal decomposition. Carbonates don't need to react with anything else. If you heat them, a lot of them will actually break down on their own. Not all of them, by the way. Sodium carbonate won't do it. And sodium hydrogen carbonate breaks down to make sodium carbonate. So there's some interesting ones, but we'll do those later as we meet them. Alright? So that one doesn't require balancing at all, but just want you to know it as an example of thermal decomposition. Okay, left the hardest till the end. What's happened here is aluminium has been put into boiling water and it's just kept boiling. That's the only way you can really make this reaction work. Once it starts, it keeps itself going, which is quite nice. So when this happens, you actually do make hydrogen gas, just like when you put any other metal in water, it'll make hydrogen gas. So it's got the potential to actually be quite explosive if it gets hot enough. So we find this a really hard one to balance because you've got lots of numbers of the hydrogens that's been split up, whereas they've all come from water. So it makes it really hard to do. So one of the things that I'd recommend you do is you start by going, well, there's 3 oxygens, so that would suggest there's going to be how many waters? And that'd be 3, okay, because it's got 1 oxygen in it. So I go 3 there. That gives me 6 hydrogen atoms, but over here I've only got 5. Okay, well that didn't work, because if I double this one, I end up with 7. So it's not worked. Alright, so I'll get rid of my 3, that didn't work. So you have to be prepared to make a mistake, and mistakes are okay. But we now have to go back to square one. If there's 3 oxygens in aluminium hydroxide, this has to be a multiple of 3. 3, 6, 9, 12. It's not going to be any higher than that. 3, 6, 9, 12. So let's try the next one. Trial and error a little bit. Let's try 6. Right, so because there's 3 oxygens here, this has to be in multiples of 3. 3 didn't work because the hydrogen's not balancing out. Let's try 6. If I have 6 there, that means I need to have 2 aluminium hydroxide, so I've got 6 oxygens. That means I need to have 2 aluminiums. Now, on this side I've got 12 hydrogens. On this side at the moment I've got, there's 3 in there, times 2 is 6. So I need a few more H2s to get this side up to 12 hydrogens. So I'm just going to do a little bit of a tally sheet down here. This is just for the hydrogens. At the moment I've got 12 on the left and 8 on the right. So I'm going to need to have another 4, which means another 2 molecules of H2. So I'm going to need 3 of those. Now, I always get worried about these ones because I've had to go backwards and forwards a few times. So I tend to be very, very careful and actually add up every atom in these ones just to make sure. So I'm going to check. Aluminiums, 2. Yep, good, I've got 2 there. Hydrogens, 6. 2 times 3 is, sorry, not 6. 6 waters, so 12. 2 times 3 is 6. 3 times 2 is 6. 6 plus 6 is 12. That's good. Okay. Oxygens, 6 of those. 3 times 2, 6 as well. Good, it's balanced. This is about as hard as it'll get for you guys in assessments. Alright? The trick was looking for an element, and in this case oxygen, where it had to be certain multiples. It had to be a multiple of 3 in this case, so that you could just try 3, no that didn't work. Try 6, that did work, but if it didn't, we'd try 9. And if that didn't work, we'd try 12. Alright? But you should find it won't get much bigger than 6 or 7 for things. Alright? So those are some good examples of equations that you should be able to balance by the end of this week.